Hello and welcome to today's video. So on the workbench today we have the Solectria brushed DC motor controller. And if you watched the last video, it had problems with power supply and some bad capacitors, and all of the what appeared to be logic chips were all dead, or at least the ones I checked. We had NAND gates configured as inverters, and we were putting lows in and still getting a low out, which isn't right. So we know that that one's dead. So I went ahead and swapped out all of the chips. So this is the whole set, kind of roughly laid out where they are on the circuit board with a new set. Everything's been replaced except for the switch mode power supply chip. So we still have to jump start it, but we're now getting somewhere. It actually does spin. So here, I'll show you that. I don't think it's running right yet, but it does actually spin. So we still have to jump start it. So I'll turn on my 12-volt supply. Oh, I can show you that. Hold on. So before it would come on, let me turn off the light. So you can see now the green LED will actually turn on. So we jump start it and the green LED comes on. And then I can turn off my 12-volt supply. So we're now running off of the internal 12 volts being generated by, so this puts at 315-volt isolated supplies. One goes as this 12-volt, and then the other two go here to run the two high side and low side MOSFETs, or gate drivers for the MOSFETs, for both acceleration and regen. So this is now doing stuff. You'll actually see the LEDs here when we command acceleration. So let's see if I can get everything in the shot here. So if I bring up the acceleration, again, I don't think this is right, but maybe it is. I'll have to ask the customer if this is what they experience. But you go past the halfway point, which is kind of, that's what you do on the Solectria, the AMC drives and the DMOC drives and the UMOC drive. So we'll see if that's what's going on. Give it a little bit of throttle, and we start spinning. So you can see the LED turned on for the acceleration, but it's on hard, like that's on full. Like if I put on the scope, the output is full on. It does PWM, but it's such a small range. Like it's like right here. So if I back it off just a little bit, you can see it's PWMing it. And if I put it on the scope, you'll actually see it PWMing at the gate. But it's like so tiny of a range. So I'm pretty sure that this isn't how it's supposed to work. Unless it is actually current controlled. Like I'm commanding a current. Like if it's a pure torque mode, then obviously I'm just going to hit the max RPM of my motor. I'm never going to get there. But I think the current sensor is just being used as a maximum current. I don't think it's like I'm commanding, hey, I want 1 amp, and I'm, passing an amp. So in this motor, that happens to be full on, because this motor only needs about 250 milliamps to be maxed out with no load. So I'm not sure. Maybe that's right. I don't know. If it isn't, then my guess is we've got more bad capacitors down here in the circuit that generates the PWM pulses, which is all through in here. So it could be that there's more bad capacitors that just need to be replaced, and then we get more range. I might just go ahead and replace them. I've got them just to see if that changes it. But I'll show the customer this video and see if he remembers that this is how it operated, because I'm not 100% sure. I'm not familiar with this drive. But anyways, it is PWMing, so it does look like everything's working, unless it is actually supposed to be, the full range of the pot, in which case that part's not working. Regen appears to be working. Like if I have regen off, so it's turned all the way down, and I go ahead and spin the motor, you can see it spins for a while, spins free, right? Now if I go ahead and turn the regen pot until the light lights up, so you'll see the other LED will come on. So now we're in regen, and then I try to do the same thing. You can see it's definitely regenning. Like it's hard to spin. So regen appears to be functioning as well. But again, it doesn't seem like there's any control. Like, see, it's just on or off. I don't know. It's almost like it's not generating the PWM signal that I would expect. But anyways, yeah, I'll have to see what the customer says about that. But anyways, yeah, it spins. It now works. I've got. I'm gonna actually swap back in now that it's running. I want to swap in individual chips to find out which ones are actually dead, because now that I have a full set, so I know which ones are actually bad. And yeah, anyways, so that's where I'm at on this. Anyways, thanks for watching. Bye.